APJ Abdul Kalam. This session is being organized by the Dr. APJ Abdul Kalam Center for Policy Research and Analysis, and I am Shri. The session is being broadcasted live and currently being attended by the TGP, TGP, PhD, and the Faculty of I am Shri. I would like to take this opportunity to welcome my esteemed speaker, Shri A.S. Kiran Kumar, who is the former chairman of Indian Space Research Organization, serving as an eminent Indian space scientist and the former chairman of the Indian Space Research Organization. He is a highly accomplished space scientist and engineer with a distinguished career, spanning over 4 decades in ISRO, in the satellite payload and application domains. He has made immense contributions to the design and development of electro-optical imaging sensors for airborne, low Earth orbit, and geostationary orbit satellites, starting from Bharatiya TV payload to the Mars orbital mission payloads. Mr. Kiran Kumar is also a recipient of many national and international awards, including the Padma Shri Award conferred by the President of India in 2013. He is credited with the development of key scientific instruments abroad, including the Chandrayaan-1 and Mangalyaan spacecraft. A very warm welcome. I would also like to welcome directors of Professor D.P. Goyal, who is an internationally acclaimed academician and researcher. He had over 35 years of rich experience in teaching, research, and various leadership roles in few India science institutions such as MBA Gurgaon, IIT Hyderabad, and Harvard Institute of Engineering and Technology, Patna. Last but not the least, I would like to welcome Dr. Sanjeev Sir, who is at the Center Coordinator of Dr. APJ Abdul Kalam Center for Policy Research and Analysis of the Indian Institute of Management. Over to you, Sanjeev Sir.
Good afternoon. Good afternoon, sir. It's a great pleasure to have distinguished guest, A.S. Kiran Kumar sir amongst us. Sir, we are very fortunate to have APJ Abdul Kalam, beloved late President of India, as a visiting faculty in Excellon. On his loving memory, in Shillong, in partnership with Ministry of Roads and Council, has established Dr. APJ Abdul Kalam Center for Policy Research and Analysis. The center is a think tank that has been envisioned to work for the development of notice, policy intervention, policy advocacy, and capacity building of the office. For the last 5 years, we have been actively engaged with the center and the state governments in facilitating research and the governments in Project 3. For the last few years, we have been conducting Kalam Memorial Lecture of Dr. Kalam's birth and death anniversary. We have the pleasure of having distinguished scientists with us from the past, like Sri Satish Reddy sir. We are honored to have Professor Sri Kiran Kumar sir. Delighted to have you, sir. This event is being attended by PGP students on physically in our auditorium. Many other students are being attend this program through online. This program is also live telecasted on Facebook and social media platforms. Director D.P. Goyal has already attended. I also have the privilege of having Shri S.P. Agarwal, Director of No Distance Space NESA. So may I now request students. Over to you. Sir, can you please start? Then, sir, am I audible to you, sir? May I request you to kindly start?
Hello, I'm audible.
Yes, sir. Yes, sir.
I'll start.
May I request auditorium guys to kindly switch off, mute the.
I'll also start sharing my presentation. Okay. At the outset, good afternoon to all of you. Abdul Kalam Memorial Lecture. It's indeed a great privilege and honor speaking on this program. And Dr. Kalam, who has been one of the great sons of India, manner in which he started his career, the kind of heights he reached is unparalleled. And in fact, it's all a great privilege to even know him and work with him for on a few programs. So at the outset, I would like to thank the organizers for giving me this opportunity to speak on this occasion. And Dr. Kalam himself probably has visited the IIM, and then he has also spoken there, I'm sure. So today what I intend to do is take you through one of the areas in which Dr. Kalam himself worked and then contributed to the development in the early part of his professional career, where he started working in Indian Space Research Organization, and he was also one of the project directors of launch vehicle. And in fact, at that point of time, of course, I was in Ahmedabad and he was working in VSSC Vikram Sarabhai Space Center. And we did not have much interaction during that period. But much later, after he had left ISRO, and then he was working in the central government in various capacity, I had opportunity to interact with him and see the kind of personality he was. And true to the Indian tradition, Dr. Kalam also believed that it is not just science that makes science and technology that makes a difference. It is how you bring in the capability of this science and technology to address the specific problems we are facing in the country, and also believing in the traditional wisdom that exists in this country. In fact, I had opportunity to witness when he had written a book, probably some of you might be aware, a book on ascent, where actually Dr. Kalam himself had accepted the traditional concept of a guru. A guru is necessary for the spiritual enlightenment. And it was through his interaction with one such person that he decided to actually interact with more than 1 crore young students across the country. And he had made it almost a drive where he used to visit places across the country and meet students, youngsters, and not only inspire them, but also tell them about the stories of his own work and his success, and the way India needs to grapple with the problems of the various issues that the those who are governing the country need to manage, and also those who are managing the country need to learn about. And in fact, it was his tremendous drive that brought in a lot of things, including the areas where he was actually working in the areas of TIFAC, technology infusion, and then bringing in many such things. So what I'll try to do is try to go through what we have done in space in the Indian space program, and then how the science and technology, an evolving technology or an emerging technology, was effectively adopted and utilized in our country. So today, I'm sure all of you are quite well aware how science and technology is playing such a big role in our daily life, and how tools which have been developed using technology we are taking advantage of. But at the same time, we are also seeing sometimes the technology development, when it is interrupting natural cycles, how it can have adverse effects. We will touch upon this topic little later. So what I'll start with my presentation on the Indian space program. And as you are aware, it was Dr. Sarabhai who looked at when this technology of space became available in the early uh, or late 50s and the early 60s, 1957, when Russia launched Sputnik into orbit, the availability of a technology of taking things outside Earth and through that bringing in a capability of observation, communication, and the likes. So, what he did at that time was he made use of his friends in America, Russia, France, and Germany, and then brought sounding rockets in the form of kits, got it assembled in the dilapidated church, what you are seeing in this slide. And for doing that, he also had to convince the fishermen there that if you vacate this place and allow us to conduct these experiments, one day in future, the country will benefit. We will see one specific examples of how that such a thing happened subsequently. In fact, he was able to convince the scientists across the globe by pointing out to them that near Tumba, we have a unique place, which is the geomagnetic equator. And if at that place, if we conduct upper atmospheric research, it will be beneficial for the entire humanity. And that is how these sounding rockets came in the form of kits, got assembled, and then launched. One of the key things he did at that time was also conceiving of a program which was later actually touted as the world's largest socio-technological experiment. Here is an example you can see of how a visionaries were able to look at a newly developed technology, a technology for which we ourselves did not have much actually participation, but still visualizing that putting satellites into orbits and using them, communicating with one third of the globe on a continuous mode, how it can make a difference to a fledgling democracy of India, which was just after independence, 10 years after independence, struggling with the aspects of hunger, communication, education. So what Dr. Sarabhai did was actually interacted with the Americans, and what Americans were building, one of the most advanced technology satellite, ATS-6, using that, borrowing it, moving it over to the Indian longitude, and developing in the country a system which is very similar to what you are familiar today, direct to home television. So you can see a half a rack filled equipment developed at Space Application Center, and a chicken mesh antenna 3-meter diameter, using that in 2,400 remote villages of our country. Using this broadcasting capacity, the program was brought to the villagers and the both the community of farmers and the villagers, telling them about the agricultural practices, health practices, and then various information required for the remote villagers. And through this experiment conducted for over a year, India demonstrated that adoption of space technology for through broadcasting, we could make a huge dent into the manner in which the country gets prepared. Probably to make it clear, if at that time an alternate technology which was available had to be used, it was only through terrestrial towers, a microwave tower at every 1 kilometer distance. And you can imagine if that had to be set up in the 3.25 million square kilometer area of India, not only it would have taken huge development resources, time, and the availability of space-based tower at 36,000 kilometer quickly cover the entire Indian subcontinent. And this was the experiment which convinced the government that you can actually rapidly bring in communication and reach out to the entire the villagers and others in the country through communication. In fact, you can also easily see that it does not require too much of a convincing if you tell the person, the politician, that what you are speaking can be heard all over the country. Imagine this in the early 70s and 80s. So that's how this experiment, which was conducted by borrowing a satellite which was built by Americans for demonstration of their own technological capability, bringing in a usage which was very different from what they had foreseen. And this became the world's largest socio-technological experiment. Similarly, other important thing from the satellite at that time was from space looking at the cloud and cloud monitoring, and through that ability to actually not only look at cyclones but also predict when the cyclone hits a coastal region. We have a 7,500 kilometer long coastline, and in this coastline, when the cyclone hits the region, when it is known well in advance, disaster relief agencies are in a position to actually evacuate people and save the lives. Tens of thousands of lives are saved like this. So in the recent past, all the super cyclones have resulted in loss of maybe single digit lives, and even there, because some of them do not heed to the advice given, but as a country we are able to make significant leeway and then save lives on this. So today, a tremendous capacity exists in the country where disaster relief agencies are able to prepare well in advance and then evacuate people. And not only that, today there's a mobile technology is also used, and national database for emergency management services, and establishing control rooms and connectivity. Not only that, we are also providing through international charter information to neighboring countries and other places. Another very important aspect of space-based activity is ability to communicate. So starting with broadcasting in 1975, India started developing its own communication satellites, and gradually it has built starting from INSAT series. Today we have a number of satellites providing the both transponders and high throughput capacity, where the gram panchayats are expected to be linked through this space-based communication system and provide to even remote places high bandwidth connectivity. And these are the activities that have gone on. And enabling access to basic services of health and education. This was another aspect which space-based communication and broadcasting provided. Telemedicine, which is a way of linking people in remote places like Andaman Nicobar to start with, but even other places much before what we saw today, how the COVID was actually negotiated through tele consultancy, etc. Much before ISRO had conducted these experiments and linked super specialty hospitals to remote places, and then enabling the delivery of health services. And similarly, in terms of education, providing remote classrooms to primary and secondary schools and to many faraway places where ground-based linkages, etc., are difficult, were all attempted, and it was made on an experimental basis, and activities were carried on. So apart from broadcasting and communication and weather forecasting, what India has also done is in terms of navigation, it has come up with a unique solution. Whereas you are familiar that globally, the Americans, Russians, Chinese, and Europeans have a constellation of between 24 to 32 satellites for providing the services which through a small gadget, handheld gadget like your mobile, you can get to know where you are. And this kind of a service for India, using a constellation of only 7 satellites operating in a domain which is not low Earth orbiting or medium Earth orbiting, but using geostationary satellites, we came up with this concept. And today, Navik is able to provide on mobiles and other equipment the location to India and beyond Indian borders up to 1500 kilometers. In addition to that, there was another program called Gagan, where GPS aided geo augmented navigation, where a gadget fitted in an aircraft enables the aircraft to keep track of where it is and also communicate with the ground state, the terrestrial towers, and then communicate with them. Probably you would have seen in the recent past, SpiceJet and Indigo are able to land using this Gagan enabled system in remote airports also, or the second tier and third tier airports. And this capability of Gagan was a void in Indian subcontinent, which was filled by this system. And today this was established along with the Airports Authority of India and the Director General of Civil Aviation, where using a number of ground stations established across the country, this service is being provided to the country. And then this is another very interesting case study of how what Dr. Sarabhai actually told the fishermen when he conducted the initial experiment became a reality. And today, Indian fishermen are getting the benefits of the advanced technology of launcher, satellite, and instruments. See, from 1999 onwards, by looking at the color of the ocean through the satellite and through the color identifying the chlorophyll, and through that the food chain of the fish, it was possible to tell the fishermen where they should go for fishing in the oceans. So that's called a prospective fishing zone map. And this information in the early or late 90s and early 2000 was being provided through the telex services or even pager systems earlier. But today you have got mobiles as well as a small gadget which is battery operated, is fitted into the boat of the fisherman, and this battery operated device communicates with Navik. Not only will it be able to locate itself in terms of latitude, longitude, there is an app which communicates between a mobile and this gadget. And though the mobile need not have any connectivity to terrestrial tower, you can easily imagine when the fisherman carries it beyond few kilometers into the ocean, no terrestrial tower will have link with the mobile. But then this mobile interacts with the gadget fitted in the boat and through Bluetooth or Wi-Fi, and then through the app, the fisherman gets in a video compass mode direction where he has to go for fishing. Not only that, in his mother tongue, he gets alerts about weather vagaries or even sea state roughness. If it is going to get affected, he will get a warning that next couple of days could be problematic, you could return. And also you would have been seeing in the papers, many of the fishermen are caught by our neighboring countries because they stray into their water area, and even for that this gadget can give them an alert. So here is an example of a person who does not know reading or writing but still makes the use of the most advanced technology of launch vehicle, satellite being put into orbit, applications, and then his livelihood is able to handle. And in fact, from 99 onwards, when this service has become, the availability of prospecting fishing zone information became available, studies have shown that every year India saves almost 10 to 15,000 crores because of the petrol and diesel consumption reduction, and also the time which the fisherman saves in reaching the target and assured capturing of the fish. So in this manner, this example shows how what was conceived in the initial period became has become a reality for the country. And then information from space-based observations provides inputs for various numerical weather models, you can easily understand that any model requires good inputs for the model to run. And these observations are coming through space-based instruments and various equipment that are there. And through that, the models enable improved forecasting. Of course, you also would be hearing while the forecast improvement is there in places like temperate regions of America or Europe, etc. There, the predictability of weather is much better because the number of variables which affect the prediction are less. And in tropical regions like India or Indian subcontinent, the predictability is poor. So even the most advanced countries have difficulty because unless we bring in more and more observations from ground, based on radars, the improvement for the long-term prediction, etc., becomes difficult. And in this area, things are moving, and future satellites will carry radars which will be able to provide additional information needed for weather forecasting. For doing all this observation activity, a host of technology had to be developed of camera systems, starting from Bhaskara, which provided a 1 kilometer resolution. Today, we have satellites operating, providing sub-meter resolution images and images every few minutes. And in fact, cloud cover and temperature and humidity profiles. Today, every 15 minutes, Indian subcontinent is covered using the satellites we have in operation. And you can also imagine that when you are looking from space between June to September, we are covered with clouds. So how will we be able to see anything? So because of that, many of the optical and infrared instruments, they are seeing only clouds and cloud patterns. But in microwave, the microwave wavelength, it is like we can see through glass. Microwave signals can penetrate through clouds and they can see what is happening. So we have also built many microwave instruments and then providing data for various activities. So apart from this, space science is another area where it is essential. You can use your ability to orbit around Earth, not only to look at Earth, but also look what is happening beyond with understanding about the space weather so that you can provide necessary information for weather forecasting or even to understand the universe, looking at planetary bodies and other things. Space science is an area where the activities have to happen. And in the context of today's development of space becoming the fourth frontier, these capabilities become essential. And what India has done is not only low Earth orbit, geostationary, going to Moon, Mars, and then future is even going beyond that. So for all this, you can see that you need to build technological capability of going farther and farther and then going beyond the gravitational influence of Earth and being able to communicate with the gadgets what you have designed and put into orbit millions of kilometers away. So all the technological developments required for this are the things which are done. And you are quite familiar that India performed this Mars mission and showcased how even though the resources are limited, you can actually conceive of ideas in a manner very different from what others have done and make the best use of your resources and capabilities and achieve significant things. Here again, in terms of Chandrayaan 1 and Chandrayaan 2 Mars mission, what India demonstrated in Chandrayaan 1 was, though man had landed on the moon and a lot of probes had done in situ observation, credit for discovering the presence of water molecules and OH molecules on the moon's surface goes to Chandrayaan 1. And today with Chandrayaan 2, we have actually gone one step beyond, and the kind of spectral instruments which were measuring these capabilities are doing very significant work and it is enhancing. And Mars mission itself demonstrated to the country that we can take up very difficult tasks and perform them even with limited resources, etc. So Astrosat is a satellite. Before the arrival of James Webb Telescope, this satellite had in the ultraviolet region one of the most sensitive and highest angular resolution instrument providing data. And using this, we were able to provide to our scientific community virgin data ahead of any other people for them to perform their own research. And this satellite provides Indian student community an opportunity to look at the celestial objects and perform their research work. And then many instruments which have been developed. One of the key things that has happened is providing digital elevation model for the entire country, so which becomes a backbone for a lot of the developmental activities of construction, whether it is road or buildings or cities, smart cities. So all that this requires three-dimensional data being available. So we developed instruments for providing such a thing. Microwave sensors I talked to you about, telling this gives you an advantage because you can see both during day and night, and it carries its own source of illumination, so you don't depend only on sunlight, and it provides significant capability. So today you have a large number of instruments generating data in different wavelengths, and then you have a digital elevation model, you have navigation capability, and then computing systems using models and techniques. This is being adopted for addressing the issues of socio-economic security, sustainable development, disaster, disaster risk reduction, and governance. And in all this, empowering the society for planning is one of the things that is done. And you can also visualize the task of when you are trying to bring in new technology and new way of doing things. It is, you have to actually convince the users that new capability is a mechanism which helps you do things quickly. But then there are always, you would have heard of early adopters or late adopters or laggards. That means basically human beings are not easily amenable for accepting changes. So you need to convince them. So while the Forest Survey of India started using the space-based inputs quickly, other departments started adopting both till they got convinced that this is a better way of doing things. So it took time. ISRO, Department of Space, worked with many entities like Ministry of Earth Sciences, Ministry of Agriculture, Civil Aviation. And then in this process, not only it had to work with all these different people and convince them that new ways of doing things is beneficial. And in this, of course, you can see if the person who is running the governance, if he is convinced that we can make use of science and technology for rapid adaptation and providing solutions to the problem, things happen in a much faster way. So here, this was an activity which was conducted in 2015 when the Honorable Prime Minister is addressing almost, you can say, more than 1,000 secretaries of the central government and state government departments. After 2 days of intense interaction, the Honorable Prime Minister is speaking to the secretaries. He spoke extempore for 45 minutes, telling them how space technology can be used for the benefit of the country in terms of monitoring, implementation, and then governance activity. He had extensively used this capability of communication and geospatial technologies when he was Chief Minister of Gujarat, and then he carried it forward. And subsequently, almost all states and all places, there was a significant fillip. And some of the things is, for example, Manrega activity, where country spends between 40 to 50,000 crores a year. Today, using this geospatial technology, the system, all the information is brought into the database. So everything that is Manrega is getting recorded, and then the government is also able to plan for future. So using space, you can look at solar energy, wind energy, generate information on that. And using this, you can do in terms of planning activities and providing solutions. So for all this, what this Department of Space did is starting in early 60s from sounding rockets. By now we have done more than 200 plus missions and a significant amount of accomplishments. 3 versions of launch vehicles we have, where you have a Polar Satellite Launch Vehicle, where we have launched not only our satellites, but also 345 satellites of 34 countries. And the cryogenic engines, which were not available as a technology to us because of the two superpowers competing with each other and denying the third country to take advantage of their technology development. But then all this has been systematically happening, and India has reached a stage today where Polar Satellite Launch Vehicle, geostationary satellite launch vehicle using the cryogenic technology, all this has been developed and things are moving ahead. And the country also is looking at not only developing this, but also you need to do R&D, because as you can see, technology does not remain stagnant. You need to develop newer and newer capabilities, but for doing that you need a lot of resources. And today what department has done is primarily with the available resources, what best could be done, it has done. But the things are changing very quickly. In fact, Honorable Prime Minister had tasked Department of Space to complete the Gaganyaan program of taking our Gagannauts to orbit around Earth and bring them back before the 75th anniversary of Indian independence. But both because of COVID and other financial constraints, the program has got little delayed, but it's moving on now. Human space program is another significant capability for the country, which provides not only an opportunity for a large number of researchers, and it also opens up a new area of development. And as you can see, space, which is becoming the fourth frontier, people are moving so rapidly that unlike yesteryears, where the space technology was only conducted by nation states, today private enterprise is actually bringing in money. They are making things on their own. They are actually conceiving of space programs outside the nation states and then conducting. So in this area also, if India has to take advantage of what has been developed in the country over the last decades, what is needed is the space economy, which is considered to be almost $400 billion now, and almost going to reach $1 trillion. If in that India has to play a significant role, then the next generation enterprise and the management system will have to look at how the technology developed in the country can be harnessed and used, and we can become a significant player in the global economy, space economy, and through that contribute to India's development. So in this context only today, the government of India is changing its policies, enabling private enterprise, and also changing the way department is working for making it more and more enabling and empowering the people in the country. So also you can see that space activity, by virtue of bringing in common good for the entire humanity, working with international cooperation is always beneficial. We have done work with France, Germany, USA, etc. And we also provided this, again another example of how the traditional wisdom of the land says that the knowledge and skills you acquire should be used not only for your own benefit, but also for the benefit of your neighbors. And here, Honorable Prime Minister made available communication transponders to South Asian countries. And today this is being used by Bhutan and many of our other neighboring countries. And we are another thing that we need to understand is you are recognized only when you demonstrate capability. It is not when you claim what you can do, but when you demonstrate. So here again, while in the early period, we were actually beneficiary of the interaction with advanced technology countries. See, today India is working with USA on a program which is called NISR, which is $1 billion program, where they are spending about $0.9 billion and we are spending about $0.1 billion. And at the end of this, later this year or early next year, this satellite is going to provide for the entire global community one of the most advanced information about the surface deformation, which can help our country in terms of the bio information, forest, and then for our agriculture, and also in terms of the earthquake research activities, and the entire global community is going to get benefit. So you can also visualize that years of data collection from space can help in monitoring and then providing information for climate change studies. And then even during COVID, the capability of both the information generation and geospatial techniques were used extensively for various activities. And then if you look at in all this, the whole idea, even what Dr. Kalam used to say with respect to adoption of technology and then bringing in solution, what Department of Space and stalwarts like Sarabhai, Kalam, Satish Dhawan, etc., showed is that the technology development, availability of new technology, you should be dynamic and you should be able to think of how a new technology can be utilized and harnessed for providing solutions. So in this particular case, using it for sight, wherein it was demonstrated even before others started using it extensively for the development in the country of through education and bringing information to the rural community, sight was done. And between 95 and 99, India had the privilege of actually providing to the global community in the civilian domain highest resolution imaging system. Then Mars orbiter, how you can do an interplanetary travel with a very restricted or a novel way, making use of the limited resources. Astrosat, I was telling you how this particular technology was demonstrating the world's highest resolution telescope was built in that. And similarly, 104 satellites when it was launched. Not only was it a record at that time, but then today it has been broken by Elon Musk. But then in all this, what you see is the way things are done is different from others. And Dr. Kalam, who was actually the project director of a satellite launch vehicle, when the first launch failed, Satish Dhawan almost you can say protected him from the interaction with the press, and then he went to the press and then he took responsibility. And when the next successful launch occurred, he pushed Kalam to the podium and said, you interact with the press. So basically the idea of dealing with failures, how you deal with makes a huge difference. And you have also heard Kalam telling failure is nothing to be worried about. It's also the first attempt in learning. So in this way, if you look at the crucials of decision making, culture of leaving important technical decision making to subject experts, irrespective of hierarchy, then hierarchy not priority in technical discussion, so hierarchy should not be a priority in technical discussion. Technical meritocracy supersedes hierarchy. And then indigenization of non-accessible technology and particularly single source items, you develop indigenously, and use of accessible technology, be an early adopter. And in terms of reviews, conducting reviews on the project, setting aggressive targets and emphasizing on interdisciplinary activity. Then emotional bonding, parallel development, not serial, industry as a partner, not as a vendor. These were all the concepts that were used and then went ahead. And this how using space technology as a tool, we were able to demonstrate a different way of doing things. So now, of course, what is needed is going much beyond this. And this is where the country is also looking at and going ahead. And so maybe I'll stop here and just give a few thoughts on how the country is going and how the rest of the world is going. Space is today considered as the fourth frontier, and like man conquered land, ocean, and airspace, today he is on the verge of going full stream into a private enterprise conducting activities in space, where the private enterprise is planning and doing space tourism, space adventure, space habitation, and space exploitation of going to asteroids, mining, or setting up habitation. So in all this, in all these areas, there is a tremendous opportunity. Like I said, space economy, which is $400 billion, is very soon going to be $1 trillion. And if in this the country has to benefit, we need to find new ways of working and new ways of exploiting the technology that is developed both for management and science and technology people. This is a challenge, and this is where the approach of the government, if it has to get effectively translated, it is the young, the minds of today which has to find ways of fulfilling this. Maybe just 2 points before I conclude. One is the traditional knowledge in this country and the wisdom has always shown that the resources what are available in nature, they are actually, there is a cycle to it, and if you interrupt the cycle, you are going to do a damage to the system. So respecting the natural cycle is an important aspect which, as managers of systems and managers of technology, we need to understand. I'll just give you one simple example how even today some of these traditional wisdom is remaining. There is an example of one of the professors who was actually interacting with the tribals, narrated this story. He is going along with a tribal father and son, and then the father and son, they are actually trying to harness the beehive then for getting the honey. So the son climbs a tree near the beehive, and then he puts a blanket around himself, captures the queen bee from the beehive, puts it on his shoulder, and then all the bee comes onto his body. Then, with a sickle on his hand, he chops off three-fourths of the beehive, and then he puts the queen bee back. All the bees go back there, and then on the below, father has captured the bee, whatever that dropping came, and on his blanket, and then the sun comes down. Now the professor, management professor, asked the father, see, we all teach in management that you should maximize your returns. You should be able to take the maximum utilization of everything you are doing. But here I am seeing you leaving one-fourth back there, you are utilizing only three-fourths. Why are you doing this? Then the tribal person tells the professor, as it is, we are eating into the fruits of these bees. They have struggled and then generated this. We are taking it for our medicinal value. So we should not over exploit. We should let it grow. And this is where the wisdom, traditional wisdom of trying to make sustainable growth important, and then make sure that you do not over exploit. And what we see today, over exploitation leads to a lot of issues. And if we appreciate this, then the many of the lessons which great souls like Dr. Kalam has shown, that there is a lot of wisdom in this land, and that wisdom also needs to be blended with science and technology. And if we do that, we will be doing a great service not only to our country but also to the entire globe, because the globe is also looking at, if life has to sustain on planet Earth, it is only when wisdom, which had shown for many, many years the sustainability of life is essential, and how to deal with that. So thank you very much for this opportunity to speak to you and tell some of the things that what we have done in this arena, and also share a few thoughts on the various management aspects. And once again, let me wish each one of you who are going to be graduating and getting out of the institution, when you are doing your management practices, then listen to your own inner self and then appreciate the wisdom that existed in this land. Don't take everything coming from elsewhere is good. Even this land has a lot of wisdom. So you also are an inheritor of that. If you dip into that, you will be able to do a lot more. So let me wish each one of you a great success in your life, and wish you all a great career. Thank you very much.
Sir, I think her audio is not clear to you, sir.
No, actually, I'm not able to listen very clearly what you're saying. If you want a question answer, you can probably put it in the chat box or just say, because I'm not able to listen to what you are saying.
Ms. Porshi, if you have some questions from the students, you can pass it to me.
Better, I'm able to hear you.
Yeah, you can pass it to me. I will put in the chat box, or I can ask you, sir.
You can speak, I think. Yeah, that will be fine.
Yes, sir. Sir, I think there is certain audio issue, sir.
Okay.
So yeah, it was great having you, sir. It's my with great humble gratitude that you have accepted our request at a very short span to address the students of IIM Shillong. We believe it would be much better and honor for us if you could come down to IIM Shillong and address our students in physical. We hope so. We do conduct these memorial lectures, as I mentioned earlier, on the death anniversary and the birth anniversary in October. If you can kindly spare some time and plan to visit sometime in October or in between to interact with our students, we would be really honored, sir.
Sure, I look forward to the opportunity. I am also keen on interacting with
yes,
students
sir.
and then
We
sharing
have
whatever we can.
We have NESAC here in Shillong. We are also working in collaboration with NESAC and IIM Shillong on how do we have the synergy between two important institutions of management and space technology. Mr. Director SP Agrawal sir is here.
Yeah,
So
I'm able to see Agarwal.
Yes, sir. We have been coordinating with each other and trying to figure out how we can contribute to the development of this region. With your blessing and support, we are confident that we can do something significant and positive for the society, sir.
No, definitely it's a great opportunity linking with NESAC and then looking at how various activities can benefit not only that region but also even other places. It will be a great thing.
I will request Professor Agarwal sir to kindly put some thoughts on what we have discussed in presence of Kiran sir.
I think after listening, Kiran Kumar sir, I don't find any word actually. It was really wonderful talk as always given by sir. Just I wanted to tell everyone they have seen Chairman ISRO Kiran Kumar sir as a Chairman ISRO, and but I know personally him. He's so humble, so nice, and whenever I'm meeting him, I find him, like always there is a positive energy flowing through him, and I'm getting a lot of inspiration from him. In fact, I can tell you that whatever I am today, it is because of his. I take inspiration from him, his work. I always say to the people, what is common between the first satellite of India and the Mangalyaan? All the satellite in between, there are hundreds of satellites built by India. What is common? And the common is, it is Sri Kiran Kumar sir, who has put hand in almost all the satellite which is launched by India. So it is great honor for all of us that Kiran Kumar sir has agreed and he has delivered a talk, especially on this special day. So, on behalf of NESEC, I would like to thank you, sir. And it is my personal request also, sir, that whenever you have time, kindly visit NESEC also. So, same time, you can also visit IIM Shillong also. So, thank you very much, sir. Thank you. It's my honor, sir. Thank you.
Thank you, sir. Then let me take this opportunity to kindly propose a word of thanks. Thank you for having with us, sir. And we'll definitely look forward to have you physically in our campus, sir. Thank you, sir. Namaste.
Okay, thank you. Thank you very much. Wish you all the best.
Thank you, sir.